Hello everyone, welcome to another class of IB Physics, DP2. So, last class we finished up and wrapped up chapter 11. So, chapter 10 and 11 are together, right? Fields, capacitances, inductions, generators, and all that good stuff. So, we're going to move on to nuclear physics. And we start nuclear physics with chapter 7.1, discrete energy and radioactivity. One thing I would like to start off with in this chapter is the concepts of the electromagnetic spectrum. You might think this is a weird place to start in nuclear physics. Well, bear with me. So, you have probably seen this graph before, correct? On this graph, you have the whole range of electromagnetic waves. We start from gamma rays, which is very high energy, short wavelengths. You have X-rays, ultraviolet rays, which is above the energy spectrum of light. You have visible light, and then we have infrared, microwaves, radio waves, right? These all have different wavelengths, right? But they're all electromagnetic waves. You will learn more about them, or if you have learned waves in chapters 4 and 9, you have know more about these. But what is important is there's a particle wave duality of light, right? And we basically, when we think about light and electromagnetic waves, we think of only waves, right? We don't think of them as particles. But the truth is they act as both. And the way they act as both is there's particles of light as well. You can't detect them unless they are absorbed. So they always behave like waves until they hit something. When they hit something, they hit as if they were particles. And we're going to talk what this means. Well, the fact that they are particles, and we call a particle of light a photon, right? This is the name of a particle of light. A photon has certain properties, and the first property is, of course, it has energy, right? The energy of a photon depends on the wavelength and the frequency. So first, energy of photon depends on its frequency. So this means that when we saw the electromagnetic spectrum before, what this means is that every color, which is a different color, and every wavelength has a different size of energy inside the photon. Some very short wavelength, high frequency like gamma rays, every photon has a lot of energy. Infrared and radio, the photons have very small energies inside, right? But they have particles, so they're packages of energy. Inside each package is a certain amount of energy depending on its frequency. So just right now, we're going to call this, we're going to define this energy as being equal to the Planck's constant multiplied by the frequency. This is a very basic equation. If you don't have the frequency, if you want to do this in terms of wavelength, if you have studied chapters 4 and 9, you should know that the wavelength is equal to the velocity divided by the frequency, right? Or in other words, the velocity of the wave is equal to the frequency times the wavelength of the wave. The velocity of light is the speed of light, of course. Electromagnetic waves all have the same speed. And so, speed of light is represented as c. Wavelength is equal to speed of light divided by the frequency, and vice versa. We're going to replace this in here, and we get that the energy inside of each of these packets also can be found in terms of the wavelength, which is Planck's constant multiplied by c divided by the wavelength. Planck's constant is in your physics booklet. If you should probably know where it is, right? So open your physics booklets up, try to find it. It should be in the first pages of your physics booklet. If you have used it before, you know where it is. If you haven't seen this before, you go to the table of contents. There's all the contents in your physics booklet, including equations, constants, which is what you need. So it's on page 2. And if you go to page 2, it should look kind of like this. Actually, I have to... This is what it would look like. All the constants, and this Planck's constant is h 6.63 times 10 to the negative 34 joules per second. And you probably want to save this. If you don't open it up, you write this down right now. We're going to use it in a bit. So let's go back. So this is the energy inside of each photon. The energy of each photon depends on the wavelength of light. You probably have already studied this. If you haven't, this is all you need to know. And we're going to go to the next vocabulary question, which is something we call a quantum. And this is the same word quantum that you use when you describe quantum physics, quantum mechanics, right? It sounds like a very hard word, but it actually just means package. Small package, right? The actual definition comes from Latin. It's the same root as the word quantity. And we call these photons quantums because each one has a quantity of energy. Each one is a package of energy. So every photon is one quantum. Right? So this is just to clarify, this is not a hard word or anything. It just means package. Quantum is just the Latin root used to describe this photon. So when you describe quantum mechanics, it's the physics related to packages of energy, right? Small quantities of energy. Next word we have to find is the word discrete. And the word discrete, you've probably seen this before as well. If you've done chapter 5 or any other type of physics, or mathematics is indeed as well. Discrete means only certain values are possible. And what does this mean? Well, they're like integers, right? In integers, only certain values are possible. Decimals, all the values between two integers are not integers. So they are, so only integers is a type of discreteness, right? Integers are discrete. And the question is, does it have to be whole numbers or integers? And the answer is no, right? You can define it however you want. So if you have a number line, start at 0. Discrete would just mean that only certain values are possible. You can space them however you want, right? This is discrete. It means that only these values in blue are possible and nothing in between. And that's important. There's nothing between these. Okay? So this is called discrete. The antonym of discrete is continuous. So you're going to put antonyms, probably take your letters. Antonym is continuous. And this means all values are possible. No matter how small, it includes irrational, rational, any fraction, any decimal. Everything is possible.